Hello, everybody. How are you all doing? We have the Enceladus here. Maybe? Are you there?
Hi,
Yay,
friend.
she's there. Okay, cool. And we're going to be trying out some fun stuff for y'all tonight. We have this is C as an additional language. So the Enceladus, who's normally an astrophysicist by day, has decided to learn some C by night. So we're going to be doing, we didn't have the Python session earlier. We were doing some editor stuff. It was acting a little unstable, so I just cut back to the old version. But we're going to be focused today on, learning tools aside, the stdio. So this is a standard input and output in C. We're going to go over some of the basics related to that. So I'm going to just open that up. Thank you, everybody, for dropping by. And I hope that people with haircut and yard needs are getting everything sorted out, like Nathaniel here. So, and I can't even imagine what that's like with a mask. That doesn't sound fun at all. So, all right. You might notice a little more audio noise. We were just seeing in the little warm up that there's might be some Skype nastiness. So we'll try to be careful with that. If it gets really bad, we'll cut back over to Discord. So, what are we doing? We have a whiteboard screen. All right. Now, the editor that we're back in is kind of the normal one. This is all sorts of craziness here. We're in learn mode. Yeah. Okay. So here we actually have the Enceladus up. So,
Hi, guys.
hopefully, and chat, keep us honest in the event stuff stops working. So I'm just I threw the glove on for whiteboard goodness. So I think we're going to cut over to that. Yeah, we're getting fancy tonight, Sunny. So. Okay. I'm going to cut to our whiteboard. Where's our whiteboard? Where did I do? Oh, here it is. All right. So we're in topic 5. And I guess we have green. Is that... What? How about this? T5. This is about stdio. So this is the standard input and output. Going standard being not so standard, but it's been around for a long time. So we're going to cover 2 parts of this today. Like our first part is going to be around handling strings. So this is some of the stuff like strlen and all that. Comp and etc. And then later on, depending on how we go with topics, and this might be a little too much, and that's part of why we're debugging the lessons, is file handling. So this is ANSI style file handling, and we're aiming for, I should mute your typing sounds. So this has this is ANSI style. So this is stuff like fopen and fclose and all that stuff. So this is kind of a reach goal. So we might just end up staying over here. All right. Well, what are these things? Before we can really talk about any of this stuff, we need a new color. I don't know about that color. Let's come over here. Do C programmers not pronounce std as stood? Standard, I guess, would be the right way to say it, Nathaniel. I'm not really sure. No, we're not doing libuv, Sonny. Discord. We'll get to that later. Okay. Great. So yeah, and libuv is, I guess, more standard actually to her point. So, all right. What do we have down here? In order to be able to talk about strings, we have to recap some of the stuff that I'm sure the Enceladus has forgotten. So, how do we represent a string in memory?
What do you mean?
Yeah.
Yes, I've forgotten. Yeah.
Okay. Well, in Python, we just call it str and we say stuff, right?
It's a series of characters.
Yeah, it's a series of characters. So series means array in C.
Okay.
So, and if we're going to go with a series of characters, then it would look something like this as a type. So this has a bunch of characters. This we learned are really, this is a signed type that I'm using, but if we used our new fancy types, this would be a uint 8. Because we want the unsigned type, which in the old classic world would be unsigned, because we don't want to talk about negative characters, right? Negative. What's a negative character?
It just means that you're looping back around.
Yeah,
right.
It doesn't. So it's just doesn't make any sense. But yes, you're right.
It doesn't make any sense. But like the way that I think you described it to me is that the reason why we want the unsigned and the signed is we want to be able to say that, with the same amount of memory, we want to represent the same mathematical absolute value, if you will, like same difference. Mm-hmm. So like, from negative 10 to 10 is 20. And so either we can go from 0 to 20 or we can go from negative 10 to 10.
Yep.
And so being really specific about whether or not we want unsigned or signed matters because of the range of numbers that we allow ourselves in memory.
That is correct. That's
yes.
good memory.
Yes.
Yes. That's no, you don't get to drink yet. What does that sound?
No, I wasn't drinking.
Okay. Second half.
I was saying yes, and I was like flexing.
Oh! I thought that was the pop sound I heard.
Victory dance. No.
Okay, that's good. C victory chance is good. So this is normally the largest number that we would represent. This is all one. So a character or a uint 8 in this case, because we're only worried about the unsigned case, is 8 bits wide. So here's 8 bits. I have them all set to 1. What number does this turn into? You may remember, you may not.
If you can give me a second, yes. So
I don't want to. Don't. It's not worth researching.
Right.
Okay.
Yeah.
But if we go back a little bit to our bit math, this is basically going to be 2 to the 8th minus 1, which is 255. So this is a 255 with all ones and with all zeros. 0, 0, 0, 0. It's still 0. So our range is from 0 to 255. If we had signed it, we would end up in this sort of like 127 to 0. We don't want to have a negative 0. This is bad. On down to a negative 120. We stick the extra number here. I'll have to double check that. I forget. But yeah, I think all ones is a negative number. So it's actually a negative. Yeah, that sounds right. Yeah, because we did our 2 complement stuff. So
right, so it's a negative if it's signed because the first bit coming from the left at least indicates sign.
That is correct. Yeah, you're remembering. That's good. This is usually that sign bit. We do a 2's complement because we want to avoid this problem and some other stuff we talked about. But all we need to worry about is that typically when we're talking about a character, we really mean an 8-bit thing. We're not going to get into the higher code planes yet or the characters that are in Sunny's screen name because they would not fit in 255 values. This is Korean, so it would actually fit if we encoded just those alphabetic symbols, but then there wouldn't be room for other stuff. So anyway, we're not getting into that. We're worried about the simple case of characters. So the original 7-bit ASCII plain and then some extra stuff. So that's one character. This means it's an array of characters. It works pretty much the same way as a Python array, except we have to manually specify the memory. So if I want a string that's going to be like, by the way, this is sort of Java syntax when you put this right next to here. So we're going to put our variable name in. We're going to say something like char, some string. So we'll just call it str for the moment. And it's going to be however many characters wide we want. So say like it's 5 characters wide. So in memory, I'm going to get 5 8-bit things next to each other. So how many bits?
Sorry, I was on mute. So that would be...
That's just 5 times 8.
That would be 8 bits. Yeah. And then, you saying we have a length of 5 or we're only specifying that one character? Because if it's that one character, it's 8.
That's correct.
If you're saying
one of these is 8
string,
bits.
It's 40.
Right. But this whole chunk, if I take 5 of them consecutive, I'm going to have 40 bits. So this is basically shorthand for saying 40 bits, and I plan on accessing it in 8-bit chunks, right? Which is kind of what this is about. So, here's chunk 0, 1, 2, 3, 4. All right. This is actually the beginning of how we represent a string. We did cover this really briefly. In C, I told you there's a little bit of an oddity with classic C strings, and that was what character goes here at the end. If I have a 4-letter, like say I have like a good 4-letter word, like
the null character.
CDEC. CDEC-L doesn't fit. So let's pick a word that fits into 4. Like if Sunny had didn't have a Y, it would be like sun. Okay, so we can represent
but it would
that.
be 5 characters because of the
Yes.
null character, right?
Exactly. There's an invisible null character which is implicit in this string. So this last thing is going to be all zeros, right? Because all zeros is the same thing as the number 0. Mm-hmm. Okay. This is kind of where a lot of C programmers get into trouble, is forgetting about this null byte. So I'm going to tell you about it 40,000 times. So what we're going to do with that is we're going to start laying out some memory. So for all of these C functions, we need to start saying like some simple stuff. Like, so if we have like 2 strings, say, why don't you pick 2 strings?
2 strings. Hello world.
Okay, so hello and world. Mm-hmm. Hello and world. Okay, so memory representation of these, how many bytes do they need? So they're both 5 letters, right?
Mm-hmm. And each one of those would be 8 bits, which is 1 byte. And so the first one would need 6 bytes, and the second one would need 6 as well.
Yeah, they're both 5. So it's a convenient example you just chose. So we need 6 bytes because these 8-bit chunks, because we have to worry about this null thing at the end. Mm-hmm. So in memory, this looks like if I just expanded one of these, and each one of these lines is 8 bits, then I would have a W, an O, an R, an L, a D, and then this null thing. Mm-hmm. And same story with hello. You know, I would have HELLO and this null thing. Okay, so if we're scanning through this, if we had to write a for loop to kind of go through this, and I know these C-style for loops are new, but how do we, so we would want to sort of like start here, and we would want to proceed down. How do we know when we're at the end of the string?
You reach the null byte?
Yeah. So we would go here, and then 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 we would go here, and we'd look and we'd say, uh-oh, done. Stop. And I'll even try to give you a... it was going really well till that last line, but I was feeling it there. All right, so this is a stop. Okay, so we have to really be careful about this because we don't know the size of the string when we're scanning through it. In Pascal, we used to store like the string length up here in the first byte, so we would say 5, and then these are the 5 bytes. So Pascal could actually set up a proper loop, but the problem with that was that limited your strings to being a maximum of however big 1 byte was, which in this case was 255, right? Assuming that you allowed a 0 length string as well. So C got away from that. C strings don't work the same way as Pascal strings. They adopted this null byte convention. So we basically have to kind of scan through the whole thing, and we have to look for a byte. And that's how we know we're done. Which, between a for loop and a while loop, what does that sound more like?
I feel like it sounds more like a while loop.
They both work, by the way.
You know, while the character isn't a null character.
Yeah.
Do this action.
Yeah, except you're also going to want to set it up as start here.
Okay.
And each time you're going to want to say advance by 1 byte.
So then that leans you more towards the for loop.
Yeah, so a for is I mean, to be honest, they're both good. Didn't really mean to ask a trick question, but it would be, I would think of it exactly the way you just did. I would start with the while because you're more worried about a complicated terminal condition. So you're going to say, while it's not this thing, right? You know, while we're not in this null byte, kind of keep going. So, and then we're going to say like, okay, start here and then keep going, and as long as it's not this thing, and then, you know, just keep on incrementing. And that's actually how a lot of these things get implemented. So if we were going to do this. Actually, why don't we do this before we go any further? Let's warm up with that just to kind of get ourselves into the right code mode. So I'm going to switch over to our learning screen. Oh, and just so you know, this is the part that we're talking about. So we're in topic 5 from our coding with some guy stuff. Okay. You're up. You're driving.
Okay. All right. So am I making a function to print each of the letters of a given string, or am I just writing? Okay.
You gave the example.
So
we have 2 strings. What are they?
So I was, oh, okay. So I was thinking more like, I like print strings.
We can write an arbitrary one. That's fun. Except string's not a type because it's C.
Oh, okay. Hold on.
You're going to get yourself into a little bit of trouble with the function, so let's just work in main for the moment. I'll tell you why in a second.
So.
Hey, what's up, Alt F4? How you doing?
Hi, new friend. Okay, so here's where I'm stuck. Like, I have an intuition about how to approach this.
Yeah, let's go with it.
Because strings aren't types in C, like my Python intuition here would just be to say, you know, like I have some string, right? And so I can say for I in range length of string. Yeah. And I understand that's not how things work in C. Yeah. But my issue here is
because we have to implement the string length. We haven't gotten there yet.
Yeah, and I want to use kind of that null character logic instead of relying on kind of a length.
Yeah.
A length. And so, but C requires that we like declare everything. And so for me to even think about this loop, I feel like that the thing that I am looping over needs to be declared, but I can't declare it because it's not a type.
Let me start you off. So I'm just going to take your example here, which is I'm going to call this
such a problem, C.
No, you wanted to learn C, right? Okay, so here's string A, and we're going to call that one hello, exactly as we have in our example. And
I thought we couldn't do that.
Sure we can.
Can't have it be a character because it's not. But it's not a character. It's a string.
It's a string in C is an array of characters.
And the brackets there are a cheaty way of saying basically string.
Well, it's actually just array of characters, right?
Okay, all right. So, Alt F4. That may be true. It's starting
language,
to feel like
Alt F4, language.
This is a minor friendly stream until we reach the after hours portion.
yes.
In which case
until the bottle of scotch opens, but we'll get to that later.
I try.
Okay, you do try. I try. We're trying.
I do. All right. So. Okay. All right. So.
By the way, I shouldn't be showing you this super cheaty syntax yet. So we're gonna call this. We're gonna size these.
Okay, so that's throwing me a little. I'll be honest, because to me, the brackets with the number with the integer indicate indexing, but here they indicate size.
So
like I would expect
you're right in both.
:6.
No, they're both right. In the case of a declaration, it specifies a size. So this is a declaration because this is like you're declaring variable string A, you know.
Let me make a note of that. Okay. So
So if I did this, like if I just said, remember put char.
Size. All right.
Okay. Yes, Strophium already knows what I'm going to type. So if I did put char of string A 0, then what do you think I'm going to get out? So I'm just going to comment this out so we can actually run this program.
H.
Yeah, and we figure that out because, if we did this right, yeah, we did. We got our H. These are both senses here. So this is which memory address in the array. This is like dereferencing the array. And so that basically says start at string A and go 0 of these over. So we know that these are 8 bits apiece. So it's going to jump forward 0 times 8, which is 0. and that does what you think it's going to do. If I did this, what am I going to get?
E.
Yeah, right. It knows the size of one of these strings elements. The size is 8 bits because they're all char. So it's just going to jump over by that much. If I did like an array of integers, like if I did like, some numbers and I said, okay, these are 3. How big is int typically? For our case, I told you only have to worry about
32.
Ints. Yes, you only have to worry about ints being 32 from now on. So in this case, it's going to do the right thing. If I tried to I can't use put char on it, but it would know that the size of that thing is 32 each, and so it would jump by chunks of 32 because the declaration gives it all that information.
So it's storing 96.
Yeah.
Okay. All right.
Yeah.
Gotcha.
This declaration says we're going to allocate 96 bits worth of memory.
That makes sense. Okay.
And
all right.
this type just sort of tells you how big each one is. That's kind of like for convenience. It's like a view into memory like we talked about. And this says there's 3 of them and they should be consecutive.
Consecutive.
Oh, in an array,
in what sense?
They're guaranteed to always be consecutive memory locations.
Consecutive memory locations.
Yes.
Right,
so that's why when I'm drawing on my model here, which I kind of had, this isn't like abstract. Like this is like if these things are like when I just did my example here with numbers, and numbers was each one of these is an int, and there were 3 of them, then each one of these lines is going to be 32 bits wide. So actually, if I was going to draw this to scale, then this is like the int numbers array.
Yeah, that makes sense.
So this first one is 32 bits wide. All of these are 32 bits wide. Okay, so but these are 8 bits wide because they're characters. So this is telling me the width of each one of those positions, and then this is sort of telling me like how many, but you're guaranteed that they're going to be right next to each other in memory. So, cool. That's important for later.
Okay, no, that makes sense.
And sorry, Strophium, is that not a normal word, contiguous? Have I been too close to programming for too long? I thought contiguous got used outside of programming.
No, I think so it made sense to me. Consecutive versus contiguous was actually where I was getting mixed up. So for me, when you say consecutive numbers, I'm thinking that mathematically, and I thought you were telling me if I put numbers into an array in C, they had to be consecutive in terms of numerically.
No, just in memory.
Contiguous spaces in memory, which makes sense.
My bad. Okay.
No, you're fine. No, that's the math brain taking over the programming brain.
Okay, so let's get the programming brain on the fore. So you were back here on your loop.
Yes. Okay. Right. What is the like symbol or the way to reference the null character?
Alt F4 is like I need to like make a channel thing for that, like calm down, senior engineer. Like I'm just gonna have to make that like cash in points and like it'll just hit me or something. Like, all right, calm down.
Should have like a little animated thing pop up, and people have to watch for a
calm
certain
down,
amount of time
senior
and
engineer
bits or something, and then they can use them.
I'm gonna make a note of that. I like that. Calm down, senior engineer. Bits cash in.
Which also, by the way, as a not senior engineer person, it is very strange for me to be viewed in that senior position now a lot in work. So having people come to me with Python problems or data science models and need help, that's like new to me. And it's cool. It's a cool feeling, but I mean, I'm still kind of getting over that imposter syndrome of like, why are you coming to me? I don't know anything. I'm like, wait a minute, I actually do know how to solve this. Okay. And it's a neat feeling, but it's going to take getting used to, I think.
Yeah. Totally.
But so back to this for loop. How do I reference how do I reference the null character? Like, is there a symbol?
Sunny actually just gave it to you in chat. So the null character can be specified like this. Sunny's on your side.
Yeah, I know. Sunny's here to help. This is awesome. Okay, so
don't read chat, she says. Yeah, it is cheating. No, she can read chat.
Let me chat a little bit. All right. So while this does not equal Lordy. All right. I like my spaces, but you see people don't like spaces between things, so I'm trying to all be proper and make it all smushed together so no one can read it, but people who think they read C. All right. So let's think about this. Start with I being 0 and then
chat is already kind of preempting where I'm going to be taking you.
I'm not watching. I'm
no, that's good. Don't watch because they're
I'm trying to think this through. Okay,
they're hinting out.
This is going to be terrible. Oh, hi there. It worked.
It worked.
Ish.
I
wait,
like it.
Hold
Can
on.
we? And
nope,
also,
nope,
just
nope. Stop. I know where you're going. Shh. Where are we going? So I need to. Well, I don't think I can do that with print. I can't do that with put char, so I might need to go print f for that to do the new line because I think that's where you're going, right?
No, you can put char new line if you want. I wasn't going to do that. I was actually just going to fix a little spacing. Nothing.
That makes me way happier, but everybody was hollering last stream about how I needed not spaces between things. I'm just trying to smush everything together now to look proper.
Hands are off the keyboard.
All right, I don't know if that'll work. Let's see. No. Okay, hold on. Let me clear the output. Now nothing's happening. Okay, so it's very angry at me. Wait, is this because of this whole, like, single thing, double thing happening in C? Yes, I need this to be single quotes. There we go.
Okay, I didn't touch it.
I figured it out.
I took my hands away for a second, though, so I totally didn't touch it. Okay.
C reminds me of, like the picky auntie when you're setting the table. It's like, excuse me. The forks don't go there.
Oh, yes.
Excuse me. Your salad plate goes on top. And you're like, oh, God, what'd I do wrong? And they just stare with that, like, they don't give you any helpful advice. There's no, like, error or anything. They just kind of stare with that condescending look of, like, are you sure you're done setting the table? And then you're like, oh, God, what'd I mess up? And you go back and you look through and you find it.
All right. We're gonna get is that a NASA sweater you have on?
Yep.
That's pretty awesome.
Working from home. I'm, like, comfy clothes.
Oh, I've never seen sweater knit NASA with that A lambda thing. It's very cool. Okay. So we're going to get unsafe because that's what chat is dying for here. So what we have, oh, hey, what's up, Loafbone? How you doing? So we have some put chars and these are working, and you correctly nailed we are looking until we hit this null terminator. And that's the right invocation. Now, I did warn you away from, yes, Sunny, we talked about escape sequence. I should probably recap it like Sunny just mentioned, but this digraph, I'm being a little, shouldn't be using words like that. All right, so this double character sequence.
I'm a linguist. I know what a diagram is.
Yeah, I know, but it's like I don't want to overload with technical terms. I feel like it makes the language.
No,
The language is hard
like,
enough, you know. It's
please, if you're going to use linguistics terms, like then I'm like I'm in the safe place. So
okay, all right, good. So this digraph is an escape sequence, which basically says this backslash normally not interpreted. If we want to get an actual backslash, we put two of them to denote that this is an escape.
No, this is really.
No, this is real.
Backslash.
Really, but you're only going to get one backslash in output. So if double backslash looks weird. So anyway, we have a few that we worried about. We're using the digraph for a new line like this \n. This is a carriage return, which is a little bit obscure, but you know it ends up getting used a bit. And the one that we really have to worry about is this, which is the signifier of the null byte. We could actually do null as just 0 because 0 is 0. You know, like the number 0 is going to end up being the number 0. Yeah, like this could be this. If we wanted to be silly, we could do this, and you know, it's just.
And then nothing makes sense.
It'll actually nothing makes sense. Yeah, it's nothing, and it will make sense. So that's exactly correct. So, all right. So but Sunny is right that like this despite the fact it looks like two characters, the compiler's turning it into one character. That's just our representation of a single character is the important part. So it still counts as a single 8-bit memory location like we have up here in the table. Mm-hmm. All right, cool.
Is the new line the same way?
Same way. Yep. Any of these digraphs, they're just interpreted by the compiler into their corresponding code. Like,
gotcha.
You know, T for tab, you know, carriage return. You know, any of these digraphs are one character. They're just represented so that we can kind of read them. Like, because if we actually put the null byte in the middle of the editor, bad things would happen. So, years of those kind of bugs. So,
oh Lord. Well.
Yeah, and okay, so let's go back to brass tacks here. So we have this worked. Now, before I was sort of using this notation, I just took this and I said I got rid of the specifier here. And that's just a compiler shortcut that basically says, because we're doing it in the same line as the declaration, I'm telling the compiler, you count how many things are in here. If that makes sense. Like that just says like, this is still a fixed size. It's fixed to however big this is, but this is illegal. Like if I had just this alone, the compiler wouldn't know how big to make this array, right?
That makes sense.
Yeah, so like I could either specify it, I could say it's going to be 6, and then I'm going to assign it all like STRA sub 0 is going to be H, and STRA sub 1 is going to be E, and you know, so on. But that's annoying. So we're using some compiler syntax here to shortcut us to just say, you do that. And we can go even further with the shortcutting and basically say, look, you count how many letters are there. That's your problem. So are you okay with that? Are you comfortable with that?
Yep, that makes sense.
It's not random resizing though. It's not like Python. This does not mean that like it's going to resize this thing. Like, so if I take hello and I add world to it, it's not going to resize that memory. That memory's fixed.
That makes sense. Yes, no. So it's still fixed, but
it's still fixed. It's just shorthand.
Yeah, that makes sense.
Yeah. Okay. Cool. Well, since we now know how to kind of operate on this array, if you were going to change this to print out how many characters there were, how would you do it?
So if I were to change this to print out how many characters there were.
Yeah, like we want to say, for example, in your example, you're passing it STRA. So if we wanted to know how long STRA is, like how many letters make it up, how would we calculate that?
I mean, so here you could just you could print I basically.
Yeah.
Go ahead. It's going to iterate through.
Yeah, print I.
And print fi.
Yeah, print fi. Got to get you out of Python mode. You need to give it a format specifier, though.
Oh, that's right. It's this thing. It's this.
You have to say you're passing a number.
Okay, cranky
I'm
auntie.
going to
Okay.
clear this
so,
output. So we'll just run that again. Oh, text file, but yeah, we both ran it at the same time.
Sorry, I was that.
No, it's okay. You should be playing with it. That's good. I didn't know that bug was there. So, okay. Now it put them all on the same line for you.
Yes.
Because.
I mean, I could do this.
Because we didn't new line it, right? Okay. So, all right, cool. Now the answer to my question is actually the last line there, right?
Mm-hmm.
So how do you actually do that in code? Because we don't want it printed out. We want to like calculate what it is and stick it in a number. So if we had a variable, which we called the result, and we're going to set it to 0, how do we get result to be that number from that last line? We could build a computer vision system to read the output. Train a neural network.
That seems way easier to me right now than this does.
No, come on.
So I guess what's throwing me is that in a Python loop, there's a bit of there isn't this kind of like while this particular condition is not met, you continue looping. Like that's a little confusing for me, because I guess if this were a Python loop, you could just do some kind of like, print the next to last one, and that would be easy.
You didn't want Python, you wanted C.
I know. I'm going back to what I know and trying to build from there. So like here, it's going to break when a certain condition is met. And oh my god, Jess. Okay, hold on. Wait.
Getting close.
This is C. We can't overwrite things.
Sure we can.
Can I overwrite it as long as the memory is the same?
Yeah.
All right.
Oh, thank you for the new line.
I'm trying. All right. Oh no, it's angry. Oh, well, that makes sense. That's because I didn't do this.
I is only valid in that loop.
There we go.
There you go. Guess what you just built?
There we go.
This is the string length function.
Okay. Yay, Len.
And I'm glad you asked, Guy. Where did the string length function come from? So, if we took this thing and we wrapped it up in a function, we would run into one quick little problem. So if we were going to like set this up, how would you start specifying? Like, so this is all in main. So how do I build this into a function? This is where I kind of stopped you earlier.
Okay. So in this particular case, we actually want it to return an integer. So we can say int length. And it's going to take a.
Just for fun, let's call it string length. I wish we could do that. I wish. No, go ahead. Leave it for now.
But no, if we can't do it, I mean.
No. Just keep going. Keep rolling. Just pretend I didn't say anything. Because at a high level, you're correct.
Ah, shoot.
Thank you for saying shoot.
I'm working. You know what? It's Monday. You are asking so much of me. Right?
I kind of like what you did. I'm going to tell you.
Oh, Lord.
No, I do.
Okay.
No, I do. I like what you did. I kind of like it. Just going to get rid of some lines so that it shows up on one screen.
I could probably do that in one thing, but I wanted to be able to see it. Oh no. Oh my gosh.
So let me just save you on that one, because we're using the fancy like loop scoped variable there. So I'm just going to bring your variable up to not loop scope. So I'm just going to declare it outside of this loop, which is something we didn't do in the past. No, you can go back to. Oh, I see what you're doing. Okay, sorry. My bad. I'm gonna.
I don't think because I need to do it here.
Yeah, I'm gonna undo that. So.
Okay, so hold on. I want to figure this out. So hold on.
Yep.
So. Actually, let me clear this so I can see where even the error begins. Okay, function string length error result undeclared. That's right.
Thank you,
so
Love
I
Phone.
need to go. Yep. All right. So here we go. We need to say that this is going to be result, and that's okay. So now it can't be cranky at me because it's declared. I built it. It worked. Look at it. Look at its wonderfulness.
Okay, you're using a feature from newer C, but I'm going to translate it into older C, and that's important for what we're about to see.
Okay.
Kill me. Sorry. So the issue here is that we're still counting on the compiler to be smart about the sizes. Stop it, Alt F4. Okay. So the problem here is that we're still kind of counting on some sizes. So this works in the current compiler. It's going to allow this syntax. So this is cool. We return it, we print it out. You have this right here, and we get the right number, right? It's 5. If we set this thing to run against string B, then it still probably works. Hey, not bad. Let's make these a little bit different. So, hello world.
I see what you're saying. I think I'm anticipating what you're saying is that if it eventually becomes a length that requires more memory than that which I've specified, we're going to have a problem because it can't just adapt to whatever the size
is going to be something a little bit different. So you're close. Where this is going to change is this wasn't allowed in older compilers. So we weren't allowed to pass that around, that kind of stuff. So the modern compiler can sort of tell how big the zone is and like help you. So instead, we're going to be very non-specific about it, and we're going to introduce this star notation, which you've seen briefly before, but I didn't really explain it. I said, yeah, we're going to talk about that later. Okay, so you haven't seen this really in other languages, right?
I mean, it's a bit in Python.
It exists in Python, but it's kind of weird in Python, isn't it? I don't know. I never felt comfortable with it in Python, but yes, Stropium. So I'm going old school on the style here. Sorry about that. It does multiplication. No, chat. Don't be a bad chat. Okay. So it does not do multiplication. It does multiplication when it's like in the middle of two numbers. So if you do like 2 times 3, that does the kind of star that you expect. This is part of why writing a C compiler is a pain, because all these symbols are overloaded depending on the context. Okay. So this not what Alt F4 said. This star means that this is a pointer. So you're not familiar with that in Python, right? I mean,
No.
It exists, but it's kind of weird. It's not really commonly used. Okay, then we're going to just say really fast, what are our options for passing this thing around?
What do you mean by options for passing this thing?
Oh, so what we're doing is we're passing. I threw the glove on for you. We're passing this string, in a sense. We're passing it as an argument, right? So string length, and here it's being bound to string, right?
Yes.
Okay. So this is, how do we get that whole string up there? Well, we can copy the whole thing. We can say that, okay, this only takes fixed length string. So we can say something like, I only deal with strings of length 6. Okay, and
right.
it'll actually copy it, right? It'll just say like, all right, here's your 6 characters. So when I was doing my stack frame like we did in the other week, then you would start saying like, okay, here's my return address, and here's going to be my return value, and then I'm going to pass along my 6 characters. So hello. I'm having my stack grow up because I'm just being like that today. So, except I forgot my \0 digraph. So there's my null byte. All right, so there's my stack frame. Now, in this case, I had to copy the whole thing. This is bad. What if this like array, what if it was like a whole text document? This is a lot of copying, right?
Yeah, that would be okay.
I mean, because it's going to grow with the size of however long the string is. So if the string is n, then this is going to be n big.
Mm-hmm.
So if this thing is like 300K, that's 300K of data I have to copy onto the stack. That sucks. Mm-hmm. So what if we didn't want to copy all of this frame? What if instead we said, okay, look, don't worry about it in the this is the function you just wrote, right? So this is string length.
Mm-hmm.
What if instead I just said, all right, you know what, string length, how about here's my return. This is the return address. This is going to be my value for the result. Actually, yours is defined as null, so it doesn't really, yours is void, so it doesn't really matter. This won't be here. And then what if we just said, all right, you know what? Further down in memory, not in your space, I've already allocated this thing. So rather than copying all of this stuff onto the other stack frame, why don't I just say, look, this is at memory location 7F, 2B, 8C, 1, 1. No, it would never be aligned like that. Actually, it would never be aligned like that either. Let's just say these two are zeros. So, all right, now we're actually being honest. So what is this? Yeah, it's a scary number, right? Although it's...
I mean, it almost looks like, I know it's not, but it almost looks like hex a little bit.
It is hex.
It's not. Oh, it is?
Yeah, it's hex. We're writing in hex because we're writing computer memory, but you'll notice that it's made up of 4 pairs of hex digits. Mm-hmm. And 2 hex digits we covered in the other class represents a byte. So there's 4 bytes here. How many bytes is that? How many? What do we have total? How many bits?
For 4 bytes?
Yeah.
32.
Yeah. What does that remind you of?
Int?
Yeah, it does. And actually, originally it was implemented as an int. So this is a memory address. Now, I know that this thing is going to be pointing to characters. So in terms of my view, I'm going to refer to this as character because when I'm looking at the individual things related to it, I'm going to dereference them 8 bits at a time. But I'm going to take this thing as characters, and I'm going to say, this is the address where this starts. So why don't I just take this address and send it to you? So instead, I'm going to pass along 7F, 2B, 8C, 0, 0. Oh, that was...
Okay, so we can say instead, like, instead of having to know the length.
Oh, no, we still have to know the length. Oh, we don't... Yeah, you're right. We don't need to know the length of the character array because it's still null terminated here in memory, right? Did I lose you to chat?
No, I was writing notes. I'm sorry. So I'm
Okay.
trying to remember to mute myself so that there's not a furious typing sound when I'm copying down stuff.
Okay.
So,
Okay, let's go over this real quick. These 32 bits, we're assuming that we have a 32-bit memory model in this example. So this is, nowadays you would use a 64-bit model, but it doesn't really matter. It just matters if you're consistent on your system. So this 32 bits refers to a particular address in memory. So this is the address where this happened to be stored in the other stack frame. So I want the other stack frame, the one that's in string length, to be able to access this memory without having to copy it all over. So I can just say, hey, why don't I just pass along where it is? And I'll tell you that this is where it is. I don't mean the thing, I mean where the thing is.
Okay.
Like where to find it in memory. That's
in memory.
Yeah.
Okay.
That's called a pointer.
Okay. So it's just it's like a IP address but for memory?
Yeah. Yeah, that's
Okay.
that's actually they were the same size too, because IPv4 addresses are 32 bits. So it's not the memory itself. It's where it is in memory
Right.
is the important
Just
thing.
like, your house address isn't exactly your house, it's where your house is located.
Yeah.
Okay.
Yeah. So we can pass that along and say, look, I'm not going to pass along the data. I don't want you to copy it, right? So if I actually specify that this thing was like 6, then C would actually come along and copy the whole thing onto memory as long as the size is matched. But I don't want it to do that. I want to instead
The
say,
star is a pointer.
I want to say, just send a pointer in. And I'm going to know that that's a pointer. I'm going to do slightly different syntax to remember that I'm working with an address instead of the actual thing.
So when I feed it later, when I
Oh, you're
use
feeding
that
it now.
particular
What do you
function,
mean later?
well, when in main, when I call that function
Yep.
and I give it the argument, whatever argument I give it, string b, how does it know? I mean, this just like so far C has seemed very handholdy. How does it know the memory address? How does it know where to point? Just because I'm feeding it something, is it like a kind of almost like a tag that's associated with it that it can just read?
The pointer is the tag. The pointer literally is the location in memory. Like, let's look. So if we pass this thing along as a star, and by the way, if you pass it along as a char string, C allows you to dereference it exactly the way that we're just doing right now. So you can still do string sub 0.
Mm-hmm.
It doesn't matter if it was passed as an array, like as a pointer, or if it was passed by copying it onto the stack frame. Both of these syntaxes are valid. So if I have it defined this way, then this will copy it onto the stack, and I can refer to element 0 doing this, or I can refer to element 3. But if I pass it along as a pointer, then this is still valid syntax. Now the difference is we can actually look at the pointer. So just to give you a little insight here, let's take a look at what this thing is. Now on our system, it's probably going to be an LLD for the actual size that we're running. So let's just take a look at the raw address. Yeah, this thing.
Okay.
That's okay. I can cast it, but you'll notice so that's just saying, oh, you might have screwed up here. So right now it knows that it's being passed in. The memory view is char pointer access, but I could actually map that thing back out, right? I could say, I could do the coercion right here. All right, so I clear my output, I look at it, boom. Now that's not quite right because I have my output here because I didn't new line it because I'm naughty. So let's fix that. All right.
This doesn't make sense to me, just to say.
Why not?
Why is there some weird parentheses stuff happening at the beginning of the string?
Oh, you mean this doesn't make sense, this part?
Yeah.
That's just...
When you said you were casting, is that what you meant?
Oh, yeah, that's casting. That's the cast. Right. I'm just matching the types up so that the printf is trying to be defensive and tell you, like, you might have screwed something up. That's just, it was just a warning. It wasn't an error. It still ran it. Okay, so this fits into the right size. If I go and I look at this number, what is this number? This big long number here, the first one that gets output.
Well, from what you've been saying, I think that's the memory address, right?
That's exactly it.
Okay.
And C's not being very handhold, like, because the programmer doesn't need to think about where in memory that thing gets assigned. It's okay, right? It deals with it for us. Like, we don't care where it's assigned in memory. We just care that it is assigned in memory somewhere. Okay. So that's important because what we're going to look at next is, this is the Enceladus version of this function. But I told you before, I wanted to have manual pages available. I didn't have them in the tool in time. So instead, we're going to use the Linux manual that gets copied online. So this is a copy of typical Linux manual pages. And these are normally accessed by typing man for manual and whatever page you want. So the first function we're going to look at is called this. Actually, sorry, wrong function. It's called this. So strlen, string length, calculate the length of a string. How's it sound for you?
What do you mean? How does it sound?
Oh, I mean, like, is the page making some sense? I mean, so these all have the same format. It tells you first where the thing is defined. So in this case, it's pound include string.h. So this is a string.h function. So you remember before when we were in the editor and I'm just going to move this tab over here. The first line that I would always write in the program was stdio.h.
Mm-hmm. Yeah. And
Okay.
you said that was kind of like just some shortcuts.
Yeah, that's where we defined printf and putchar and those functions. Okay, well, this particular function is a string function, so they're all included in string.h.
Okay.
So the first thing we have to do is we have to add that. So at the top
Why is
of our...
everything .h?
Oh, it just means header. It's for reasons that are historical. It's just it's not.
No worries. No,
it's
okay.
not important. It's just they're pretty much always going to be .h until you get to C++. We'll get more into that when we get to multiple files and how you write your own routines for library use. But so this requires string.h. So if we just go looking for it, it won't necessarily be there in the compiler. Okay, and then we get access to a bunch of functions. One of them is this strlen, and you'll notice it takes this const thing. Don't worry about const. That just means that you're not allowed to change it. So it takes the rest of this specifier is a char star s.
The star being a pointer again.
Yeah, that's a pointer. So that was the reason I went out of my way to show you the pointer syntax. Because all of the classic functions are going to look like this. They're not going to use the brackets. Okay. Yeah, strophium, that's C++. Typically. So what does this thing do? It takes along one parameter, which is this s thing, and it tells you it calculates the length of it, looking for the null byte, which is misrendered in this web page, but basically there's that \0 hidden in the middle. And so it returns return value. This thing returns the number of bytes that are going to be in the string. Okay, so how do we use that instead of the Enceladus version?
So
it returns a size t, by the way. So that's the type you're supposed to use. I didn't know how old the standard was that we'd be using.
I mean, so in this case, you could just say, so size t?
Size t, for our purposes, is going to be an int, but it's usually a long int. Size t is just a number that's the size of whatever your memory address size is.
Okay.
So it corresponds to
I mean, you could do the same thing here, but instead of mine, you could call, what was it, string len?
Yeah, we don't need to cast it to int, so we can actually use size t, so there's no cast.
Okay, and then what was the name of it again? Sorry, string.
strlen.
strlen. Okay.
Okay.
Oh, well, excuse me.
Yeah, no, that's all right. That's because the sizes don't exactly match. That's just a warning. Same kind of warning that we had before. So right there is the actual size I should have been using. On this platform, it's a long unsigned int is the size of one memory address. That's going to turn into... We could actually see, do you remember the operator to see how big a memory type was?
Size of?
Yeah. So how would we know how big size of the size t type is?
Well, you could just do size of length.
Mm-hmm.
This is not a function, even though I want it to be. So
And it wants you to use LD for this.
Okay.
Okay, so it's 8 bytes, which is two 32-bit values, which is 64 bits. We're on a 64-bit computer, so that's not surprising. Okay, so that's it, right? So we know that size t is really just, a 64-bit number. Okay, so great. That was surprisingly easy once we knew what a pointer was, right? Pointers, by the way, this is a little bit of a trap. This is where C starts to get hard. So
I've heard of these.
They warned you.
Pointer things.
Who warned you? Was it Strophium? Was it
the internet?
Nathaniel? Was it
the internet warned?
Who's gonna do it? Okay.
Social media.
Social media warned you.
And hearing just everybody complaining about pointers, I'm like, I don't know what that is, but someday I'll be afraid of it. And now it happened, and I'm like, this seems deceptively understandable. And if all these smart people don't get it, then I'm probably missing something. So.
No, this is. The concept's not that complicated. It's just like you were saying. It's the address, but the part that gets a little tricky is like doing the math. So we'll get more into pointer math in a future session, but we just need to know enough about pointers to understand that we're not copying everything onto the stack frame. It doesn't need to know the size. It's still going to work exactly the same way you did. It's going to keep going until it looks for the null byte. The actual implementation is a little bit more complicated for speed reasons. It typically read, depending on the library, it might read a byte. It might read 32 bits at a time. It uses an aligned access, which is kind of optimal for the platform. I've seen some pretty crazy stuff for like ARM or whatever. Okay, so we don't have to worry about it, but functionally, it's pretty much the same as what you wrote, except it returns a size t instead of an int. But yeah, same idea. All right, so now we have pretty much the same function signature. Great. What else is there? Now we know how to do the length of a string. What if we want to see if both of these strings are equal? How would we do it? Now, obviously, you know they're not equal.
Yeah.
I'm going to get them to be the same size, so we can't use strlen. We could say, oh, is the length of this one the same as that one? Like, okay, they're the same. But they're not the same string.
I mean, you would have to check character by character,
yeah.
Right? Okay.
And we would stop when we
hit the
null byte on one of them. Well, I'm glad you mentioned that algorithm because that's pretty much exactly what we're going to see. It turns out it's called Str Compare. And like all functions, it's string for str, and the other part is shortened. They tried to make things really short back in the day. They don't care anymore. This is before Objective-C. Okay, so this page is showing you, I just pulled up the die page here, and this page is showing you that there's two functions specified here. There's an str compare and there's strn compare. We're going to get into the n variants. A lot of these functions have an n variant, which we're going to get into later. So for now, don't worry about anything with the n. But str compare takes string 1, s1, and it takes s2, and it compares the two of them. And if they're the same, what does it return?
An integer less than equal to or greater than 0. Or the first n. If s2 is found respectively to be less than, to match, or greater than s2. S1.
Right, so match is
0.
Exactly. So this is a weird function. It's your first encounter with one. It returns 0 to mean yes.
Okay.
I warned you that there was no real Boolean type in C, right? You know, this is kind of why I was warning you. Okay, so how do we compare these two to be whether or not they're the same? We want to say they're the same if they're the same, and say they're not the same if they're not the same. But last miles, nothing is wrong with it. We're not using. I was originally starting with C89. Nothing's wrong with bool that was added. I like how they implemented bool as opposed to kind of what happened in C++. But commentary aside.
So repeat the question. Sorry.
Let's get a let's write a simple program that's going to compare STRA and STRB. So I'm going to delete this stuff. So let's just get rid of this. Let's get rid of this. If STRA and STRB are the same, print out they're the same. Otherwise, print out they're not the same. So we're going to use an if-else. That works kind of the same as Python.
Okay. Can I use my string length thing?
Oh, you could write it yourself. I was going to let you use the str compare.
Oh, yes, please. Okay, sure. Yeah, no, that's great. Let's use that.
No, I showed you the man page for a reason.
Okay. And they're like, here's what it looks like if you do it right. Now you try.
No. We already implemented one. We implemented strlen. So you, as an exercise to the reader, you can implement all the other ones if you want. But
oh, that sounds like a physics textbook. All right. So it returns an integer. So result.
woof.
Oh, little puppers are upset about something.
Okay, I like using an intermediate.
I'm trying to remember how to do it. States in C. All right. I'm fudging this because I don't entirely remember how to do this.
Oh, don't worry about the else. Just start with the true case. We'll add the else in a moment. We have to valid up that extra. Yeah.
Oh shoot, that's my fault. I'm sorry. Hold on. Let's clear this. Okay, so it's mad about something or other. Oh, well, that's entirely my fault. I forgot about
That's
that
totally
whole
fine.
thing there at the bottom.
Yeah,
All
we're
right,
looking at line numbers though. That's good.
Okay, so they might.
Okay, in this case, they're not the same. Let's set them to be the same. Let's just check your true case first. Okay. Cool. Now let's worry about our else. Yeah, there's no need to jump ahead into a complicated construct. We can build it up piece by piece. Looks pretty good to me. Okay, one stylistic thing. Typically, if we're putting the open brace on the same line as the if, we typically put the else on the same line as the close brace. It's common.
It's ugly.
Well, I mean, you could be consistent. If you want to not do that, you could do older style.
I mean,
it just pick one way or the other. I'm not. This is a little weird to read in modern C. Like this is much more common. But anyway.
What? Q command? What?
This is Alt F4 is telling me I'm being a senior engineer again. So he's got me. Alt F4. Yeah, it's now, as Last Miles is pointing out, it's now become pretty standard to write it this way. So you might as well just get in the habit now. Okay, so str comp, piece of cake, right?
I think so. Yeah, that made sense.
Okay. if I wanted to invert this, I could torture myself and check all the other different result types that I can get, because if string 1 is less than string 2, then I get a less than. If it's greater than, then I have all those different versions, right, in str compare. But if I really want to invert this correctly, just do that. So don't try to catch all the different cases, like, result is less than or whatever. Okay. We're only really care for right now for strings. We're only care about equality and non-equality, inequality. So the other versions of string compare, where it returns one is less than or greater than the other, they're mostly used for sorting. So like when you want to compare these two and say, is this one less than or greater than the other one? That's typically what they're used for. Okay, so that's cool. That was, and then we have one last one in that vein, which is, how do we copy a string from one place to another?
I'm guessing there's a function for that.
Yeah, there is. It's called str copy. Starting to notice the pattern yet?
Yep.
Okay, so strcpy gives you this. This is a naughty function. You can see it's already warned right here. Beware of buffer overruns. But that's why we're going to learn the end versions of all these functions later. So don't worry about that. Right now we're writing unsafe old style C. So str copy. Now, this is a common convention. You're going to have to be really careful of. It burns basically everybody who gets into C programming. But which order is the source of the copy and the destination of the copy? Which one comes first?
Oh, I see. So it's destination and then source.
That's always the case with these functions. So it's almost always destination first, then the source. That's confusing. There's a couple that will flip it later on that we're going to get to. They're kind of edge cases, but most of them follow this whenever you have these two like copies desks kind of thing.
Okay.
So just be careful about that. The most common bug that people run into with writing like str copy, this kind of stuff, is like when they do, they copy junk memory, which is where they want the thing to go into the other thing because they write it the way we write it in English, and reasons. But okay, so if we had enough space, so I'm going to change this up. We're going to add string C, and string C is going to be big enough. So let's just call this buff for buffer. So say we had this thing like so. If we wanted to copy string A into buffer, how do we do it? So how would you do it your own if you didn't know about that str copy? Don't code it, just talk me through it.
I mean, I think you would have to go character by character again, which is kind of a pain.
And what would you do character by character? This one's a lot easier than compare, actually.
Setting I don't even know how you could do that in C, actually.
Sure you do. What's at the end of the string?
The null character.
You got it.
Well, I know that you could iterate through. That
Sure.
makes sense. But I mean, can you reset characters in an array of characters as
Sure.
new characters? Yeah, okay, that makes sense. Okay, so then
but we're not copying on top of ourselves. We're copying into the destination. Mm-hmm. So this is where it's important that you don't pass the things the way we did before. So before we were passing it, like first inclination was to kind of do it sort of like this. So like say we had it sized. I'm editing string length.
Yeah, okay, had to scroll up. Yes. Mm-hmm.
So we were doing it that way. That copied it on the stack frame, which is kind of what I showed you. But then we switched around and we said, no, we're gonna pass the memory where this thing is located. Now that's handy because since we didn't copy it into the stack frame, we can edit it directly from our other function.
Yes, that makes sense.
Yeah, because now we're passing the address of where it's stored. We're not passing a copy, because normally when we were winding up our stack, like before, we had like main down here, and then we had, string length function, and each of these frames only lives for as long as the function call exists. But as soon as the frame is done, we would throw this entire thing out. So that's not really good if we copy the thing over here, because I'm going to throw that memory out, so I can't say like, oh, pass it back. It's gone from the stack. But in the case of we passed a memory address, then now we can say, okay, this is actually the memory from the other frame. So if we change memory over here, we're okay. And that's part of the reason why this thing typically, this in the manual page, you'll see that it's being passed a pointer. And that's so that it can kind of edit the memory in the other stack frame as opposed to editing its own memory.
Okay, yes, that makes sense.
Okay, that's important. that's really important. That's actually kind of the answer to the trick question I asked you at the end of the last stream, where I said, "What is? How do we return more than one value?" In this case, we have an array of numbers. So how do we return that? Well, there were a few different techniques. We could copy it around. That would be using the stack frame, but we could also do this edit thing. You know, by using a pointer, we can access the original memory and we can set it up the way we want.
Okay. I think it makes sense.
Okay. Well, that's okay because we could actually implement it ourselves. Would it help you to implement it, or would you rather just like use the one that's there? Because I think it's okay if you just try.
Yeah, I mean, I think it's just gonna be the kind of thing that's gonna take some reinforcement.
Yeah, we're gonna have to hit it a few times, I'm sure. But,
yeah.
All right. So using this buffer. Let's do it this time. Maybe we'll warm up, or actually that's really a good homework kind of thing. How do we copy string A into the buffer?
So let's see. Give me 1 second. Function copies the string pointed to by buffer pointed to by destination. The strings. Okay, so I mean.
I think we're definitely going to save file IO for next time. I just warned you about the order too.
Destination first.
I told you it's unnatural.
Yeah, it's definitely very weird. I think that.
All right, well, let's print out buff afterwards. Okay, I'm deleting some of your lines because I don't want it to scroll off for the viewers.
Yep.
Oh, we typed over. That's a issue I have with that.
I don't think I have to tell it that it's anything.
Actually, let me delete string length because we did that, right? You copied notes?
Yes, I copied that. Mm-hmm.
Okay. That's a lot of screen real estate.
But then doesn't this need like return 0 or something? And then its little last one, right?
We need a format specifier. Okay, we can use the thing itself as the format specifier. But typically when you're printing a string out, let's get in the habit of always doing a specifier for now. So this will say, I'm expecting you to pass along a string parameter, and it's going to be buff.
Okay.
Okay. So yeah, let's try it.
Okay. So that worked?
Yeah. Looks like it was good. What if there wasn't enough memory?
Then we would get that error that it mentioned, the overflow or something.
If you're lucky, you'll get an error.
I mean, I'm not sure what else it would do. I guess maybe we would only get a portion of it then?
By the way, I want to reinforce, I agree with Last Miles on this one. Actually, I've agreed with a lot of what he said, but this is always be in the habit of doing a format specifier. Don't just send naked strings out, because if you had like a % in there, it would try to interpret it as a format. That's just bad bad voodoo. So force yourself into the habit of always doing a printf requires a format specifier.
Okay.
Bad voodoo. Okay. Even though, like, in this case, it's a string, it would treat the whole thing as a literal, it would work. Don't do that. Okay. Okay, so right now we don't have enough memory. It's going to try to copy it. What's going to happen?
I mean, are we only going to get a portion of it then?
You get to keep both pieces. Go ahead, run it. Oh, it worked. See, I told you, you're lucky. Overwrite? You're lucky if you get a crash. That's what you're doing is you're actually writing into a different part of the stack frame that you may or may not own. In this case, you're lucky. There's enough room there, probably because of alignment stuff, and we're not that off. But this is kind of the beginning of danger in C, and this is part of why pointers are really kind of nasty, because it's not safe. Okay, you're used to like a language like Python, which will check. It'll say, oh no, you don't have this memory, so you're not allowed to do this. Like, C does nothing of the sort. It'll try that at runtime if you tell it. There are pedantic modes you can put the compiler into, which will do bounds checking, but it's not necessarily there, and you shouldn't count on it being there. So just because your code works doesn't mean that it's right, and that's kind of a dangerous thing. It won't always crash. And so these kind of insidious bugs could slip into systems all the time, and they do. So, okay, to TN. Oh, sorry, I missed Warrior Giggles. Got to head out. See you later. And why is C popular? And what is it mainly used for today? Lots of different stuff. It's in tons of libraries, the Linux kernels in C. There's a lot of use cases. We're more just kind of exploring it because she wants to learn it. So, it is speed. I want to be careful, Sonny. It is known as being fast. It's not that C is fast. It's that you get exactly what you know what you're paying for in every statement, right? So you can kind of see very quickly, like, this is all it's going to do on this line. This is all it's going to do on this line. There's no magic. There's no like runtime type whatever. It's like it's just going to run it exactly as it is. Other languages are trying to compete for that type of performance and level of abstraction and portability. But anyway, we're doing C because she wants to learn C. All right. Great. So I'm going to leave this to you because we took a bit of time getting through pointers, and I really should have accounted for that properly. Do you want to run into... I think we know enough about strings that we could start working with a file. Do you want to work with files today, or should we save it for next time?
So I think just because of this week, I have more of those like super early work meetings.
Okay.
Today, I'll probably say no, but
let's save
normally I would totally be up for it.
I got it all prepped. I've got a few System 5 functions. Let's just take a quick look at the system, at the Berkeley function, some of the System 5 stuff, just for fun. But it's in the same vein, so we're not going to touch the file stuff. So I'm gonna delete it. No.
No what? No.
This. So I'm just editing it on the stream.
Okay.
We're not doing topic 2. Okay. So great. Let's do a. So that was your first view into kind of memory and copying and some of the low level stuff. This is all handy, and it all requires that we're working with strings, which are character arrays that have one special property in classic C. They're null terminated. Mm-hmm. What if it wasn't null terminated? We're using that null terminator to kind of know where we're done, right? We're scanning through the string, and then we're saying, okay, this is here. What if I was like sending some data and it happened to have the byte 0 in it? Like, my data just die? Do I have to always encode if there's zeros in my data into being safe? Turn them into digraphs like it was here?
I mean, you said that it's not equal to a 0. That it's kind of like
it's the number 0. Not not the numeric ASCII digit for 0. It's actually 0. Okay. All bits are set to 0. That's the null byte. So it's 0 in the 0 sense. Okay, so I could make that illegal. Memory could never be 0 if I followed the C convention to the limit. Or I could start, how would I have to change these functions that I'm running? All of them require that they're null terminated, right?
Mm-hmm. Yeah.
So what if I drop that? What if I relax that constraint? It's not null terminated. How would your code break earlier from string length?
How would your code break earlier from string length?
Yeah, your string length function, it basically iterated, right? What did it do?
Well, so I think the issue there is it would never end if you defined it.
Yeah, because what's it looking for?
It's looking for that null byte.
Right, so what would it need to know?
Change. It would need to know the length.
Yeah. So string length would be meaningless because you'd have to tell it the length for it to know the length. So, but string copy would not be meaningless, right? I mean, I could write a string copy that doesn't use a null byte at the end. How would I do it?
Right. You would need to know the length.
I would have to pass along the length. And that's basically what Mem Copy is. So that's string copy, but not for null terminated stuff. So I'm just going to edit this URL, and I'm going to look at Mem Copy, and look, it's almost the same, dest and source, same order. Yeah, we haven't gotten to memory allocation. We haven't touched the heap yet, chat. So Mem Copy looks almost exactly the same, except one more parameter.
Yep, the size.
The size, yeah.
And that was same with string n copy or whatever. It took a size as well.
Yes, that's kind of the move to non-null terminated. It's sort of what was happening in the C library. So really, it's really just Mem Copy at that point. Like we're copying memory. So they are warning you that this stuff can't overlap, right? It'd be bad if you copied, like remember, memory has to be contiguous. It has to be like a chunk. So I can't copy over myself, right? It would be like weird. So like I'm copying this part, but I'm also writing this part, and there's going to be bugs. So there is a way to do it. It basically involves kind of like copying it somewhere else and then copying it back. But anyway, not worrying about that. So Mem Copy, you can think of it kind of like string copy, except it's, not. It's relaxing the constraint about null termination. Okay, there's an older version. This is, at the time, there were two competing standards. There was Mem Copy, there was also B Copy, which you shouldn't use. And actually, I think it tells you, don't use this. So B Copy, there's like a bunch of these B functions. They kind of came out of Berkeley, if I'm getting it right. Yeah, they did show up in BSD. So Berkeley had one version of it. They said, oh, okay, well, we're going to do B copy and B and all this stuff. But don't use those. So I'm just showing you them, not to show you them. The one thing that you have to watch out for, what's in B copy? What order are the parameters?
Oh my gosh, they're the opposite.
Life sucks on the West Coast. So... So they wanted to, like, I guess, try to fix it, and AT&T had already kind of locked it into the standard. So moral of the story, be very careful if you're ever looking at a variant of this, like, because it could be all over the place. Get in the habit of just always looking in the manual. So it's like, don't assume, unless you've been working with it recently, like, don't assume that you know what order it's going to be. There's no consistency. It's just whatever someone felt like doing that. It's a convention. In this case, the conventions were different. So now they're all in the standard. The great part about going off the standard is you have a new standard. You just defined a new standard. So, okay. That's that. I think that's it for lesson stuff. So any questions about that?
I don't think so. I think I feel good about it.